Let's take it one step further than we did before. So Mackenzie goes bowling. Her scores are normally distributed with a mean of 155, standard deviation of 12. Out of 140 games she bowled last year, how many of them would she expect to score between 130 and 145? So in the last problem, what we were doing is we were finding the percentage of her games that would be between 130 and 145. Okay, we could figure out the percent, maybe like 20% of her games. And actually, in this case, we're going to find out that it's 14% of her games. So say we're going to say, like, we're going to calculate that and we say, oh, look, this much percent of her games are there. But what is that? Because in reality, do you like say to your friends like, well, 14% of the shoes I have are, no, you actually like use a number, right? So in this case, once we find that percent, what percent of our games are in this area, then we use that to figure out how many games that actually means. Like, how many games are we actually talking about? Okay, so first things first, we have a mu of 155, or a mean of 155, standard deviation of 12, and we're trying to find first the percent in between 130 and 145. So this is going to be the normal CDF. Remember, this tells us how much area is in between two numbers on the curve. So we go to distribution, we go to normal CDF, enter, and we want to go in between 130 and 143 with a mean of 155 and a standard deviation of 12. So we have 14% of her games are in between 130 and 143. Okay, so that's what I have written here. 14%. We just used the normal CDF function, and we found that 14% of her games are there. But how many games does that actually mean, right? How many games does that really calculate out to? So here we go. We multiply this by 140 games. What's 14% of 140? Well, it's 19.6 games. So we could just round that up to 20 because there's no such thing as half a game. So about 20 games are going to be in between 130 and 145. I mean 143. Whatever.